Hey there, science fans. Welcome to another electrifying episode where we uncover the mysteries of everyday science. Have you ever wondered what powers your TV, lights, and video games? It's something we use every day but rarely think about.
It's not magic, though it can seem like it. The real hero behind the scenes is electricity, a force of nature harnessed for our convenience. It's all thanks to something called alternating current, or AC for short. This type of electricity is essential for modern living. AC is the kind of electricity that flows through the wires in your house. It's what powers your appliances and keeps your home running smoothly. Unlike direct current DC, which flows in only one direction, AC changes direction constantly, like a wave going up and down. This constant change is what makes it so versatile.
This back and forth movement might seem strange, but it's what makes AC so powerful. It allows for efficient transmission of electricity. Think of it like a river that changes direction. This analogy helps us understand how AC can travel long distances without losing much energy. This changing current allows us to send electricity over long distances without losing much energy. It's a brilliant system that powers our world. That's why we use AC to power our homes and cities. Pretty neat, right? Next time you flip a switch, you'll know the science behind it.
Now let's dive a little deeper into how AC works. Imagine you have a garden hose with a spray nozzle. If you turn the water on and off quickly, you create a pulsing flow of water. AC is similar. It's like electricity that's constantly being turned on and off, creating a wave-like pattern.
This wave-like nature of AC is important because it affects how electricity behaves with different electrical components. You see, electricity doesn't just flow through wires, it interacts with them. And understanding these interactions is key to understanding AC.
Let's dive into the fascinating world of resistors, inductors, and capacitors. These components are essential in the realm of electronics and play a crucial role in how circuits function. These little guys are like the building blocks of electrical circuits, and they each have their own unique relationship with AC. Understanding how they interact with alternating current is key to mastering electronics.
Resistors are like the bouncers of the electrical world. They resist the flow of current, whether it's AC or DC. They ensure that the current doesn't get too high, protecting other components in the circuit. Inductors are like coils of wire that create a magnetic field when electricity flows through them. This magnetic field can store energy and release it when needed, making inductors very useful in various applications. This magnetic field actually resists changes in the current, making AC behave differently. Inductors can smooth out fluctuations in current, which is particularly useful in power supplies and radio frequency applications. Finally, capacitors are like little storage tanks for electrical energy. They can store and release energy quickly, which makes them essential in timing and filtering applications. They can charge and discharge quickly, which can affect the timing of an AC circuit. Capacitors are used in a variety of applications, from smoothing out voltage fluctuations to tuning radios and even in the flash of a camera.
So why is understanding AC so important? Well, for starters, it powers our world. Alternating current, or AC, is the backbone of modern civilization. From the lights in your home to the computer you're using, AC is everywhere. It's the invisible force that keeps our daily lives running smoothly. But it's not just about turning things on and off. AC is crucial for the functioning of industries and the economy.
AC allows us to do amazing things with electricity, like changing the voltage with transformers. These devices are essential for efficient power distribution. Transformers are like electrical gearboxes. They can step up or step down the voltage of AC, which is essential for transmitting electricity over long distances and powering different devices. Without transformers, we wouldn't be able to enjoy the convenience of electricity in our homes and industries. So the next time you flip on a light switch, remember the awesome power of alternating current. It's not just a simple flick, it's a marvel of modern engineering that makes our lives easier and more connected.